Welcome back to your favorite intermediate algebra course. We're going to talk today about combinations and the binomial theorem. We're going to use some combinations. We're going to use the binomial theorem. So here's your definition of a combination. Okay, so if you have a combination of n objects taken r at a time. Now here, and what you want to remember is order is not important. Okay, last time we talked about permutations was one of the things we talked about. And in permutations, order was important. Okay, but with combinations, it's not. Okay, so the number of combinations of R, you could say it n objects taken R at a time. Okay, so n choose R is how you say this. N choose R. N choose R. Okay, so it's denoted by the n choose R or the n choose R, either of those. And you can see the formula there. N factorial over n minus r factorial, r factorial. Okay, so here's a great example. If you're thinking of combinations, you might think of a committee. Okay, so let's say we have these four students: Joe, Mario, Veronica, and Aaliyah. Okay, Joe, Mario, Veronica, and Aaliyah. Okay, so we're making a committee of three students. Okay, so we could pick Joe, Mario, or Veronica, right? That's one committee. Now, I'm not going to say Joe, Veronica, and Mario, right? Even though it's a different order, it doesn't matter. It's the exact same committee. It's still Joe, Mario, and Veronica. Okay, so don't count that twice. So you just want to make different sets of three students. Okay, so we have Joe, Mario, Veronica. We could do Joe, Veronica, Aaliyah. Okay, we could do Joe, let's see, Mario, Aaliyah, right? Let's see, which one am I missing here? Mario, Veronica, Aaliyah, right? There's my four. Okay, so there's four different committees I could make. So I have four students and I'm choosing three. Okay, four choosing three. Again, order does not matter here. Okay, order doesn't matter. So you're just saying, I just want three different students each time, right? So this fits our combination formula. Four students, we're choosing three at a time. So four, choose three. So my n is four, right? So you have the n choose r. My n is four, my r is three. So my n factorial over n minus r factorial r factorial. And this will simplify. 4 times 3 times 2 times 1. 4 minus 3 is 1 factorial. 1 factorial is just 1. And then I got 3 times 2 times 1. And I got 4 over 1, so 4. And we already showed you how there's the four committees, right? We already wrote that out. Okay, so order does not matter with combinations. Try and keep that in your head here. 18 basketball players are competing for 5 starting positions. The players selected to start will make up the first team. If the order in which the players are selected is not important, so it even gives you a big hint here, order not important, how many different first teams are possible? They say, well, it's a combination. Order doesn't matter. 18, and I'm choosing 5. I have 18 on my team. I'm choosing a set of 5. Doesn't matter what order the 5 are in. It's just picking 5, right? So 18, choose 5, and you're plugging it into the n choose R formula. So I'm plugging it into this. Okay, a little different than the permutation formula. Okay, so here we go. 18 is my n, 5 is my r. 18 factorial over 18 minus 5 factorial, 5 factorial. So we got 18, 17, 16, 15, 14, 13. I'm going to stop. That's 13, 12, 11, 10, right? Because I got 18 minus 5 factorial. I got 13 factorial right there. And then 5, 4, 3, 2, 1. So I'm going to cross that. See that 13, 12, 11, 10, and so on. 13 factorials will cancel. So this ends up being 18, 17, 16, 15, 14. is, calculator out, 102.8160. 102.8160. I got 120 on the bottom. 8568 different combinations. And I got 18 players and I'm choosing sets of 5, so 5 starting players there. Now, you should on your, we can show you this on the scientific calculators when in class, but you can also use your factorial button to help you to solve this. And a lot of calculators have an N choose R button. Okay, so if you punch in 18 choose 5, it should spit out that 8568. Okay. All right, let's do another one. What about a little more complicated here? A movie rental business having a special on new releases. You got these new releases. You have 8 comedies, 3 families, 10 action, 7 dramas, 2 mysteries. All right, part A. Suppose you want exactly 3 comedies and 2 dramas. Okay, you want 3 comedies and you want 2 dramas. How many different movie combinations can you rent? So you say, well, first of all, how many comedies do I have to choose from? I have 8 total comedies to choose from. So I have 8 and I'm choosing 3. Okay, that's the number of ways that I can choose 3 comedies from 8, right? 8 choose 3. It doesn't matter what order the 3 movies are in. That's how many ways I can choose 3 different movies, right? Now I have how many dramas here? Well, I have 7 and I'm choosing 2. Okay, so 7 choosing 2. Okay, so how many different movie combinations can you rent? So this is applying the fundamental counting principle because I have 8 choose 3 ways of choosing the 3 comedies, and I'm multiplying it by how many different ways can I choose the drama. 7 choose 2. Okay, so I apply the fundamental counting principle here, and it looks like you end up with 56 times 21. So this will end up in 1176. That's how many different ways, different movie combinations you can rent there. Okay, let's do part B now. So that's an example using the fundamental counting principle there. You're multiplying. Okay, suppose you can afford at most 2 movies, any 2 movies. How many movie combinations can you rent? So you can say, well, at most, okay, so I could rent 2. I could also rent 1. And how many of these do I have total? I have 8 comedies, 3 family, 10 action, 7 drama, 2 mystery. That would be 90. It looks like 30. Okay, there's 30 movies. So I could do at most 2. So I could rent 30. I could choose 2, right? There's 30 total movies to choose from. I'm just renting 2. It doesn't matter genre here. Or I could choose 30 choose 1. Okay, 30 choose 2 or 30 choose 1. I'm just going to add those 2 up here, and that's how many ways you can rent at most 2 movies. Okay, so this ends up being 30. If you punch that in, we won't do the formula again. This ends up being 435. So you get 465 here. Okay, that's at most there. All right, your school soccer team has 9 scheduled games this season. You want to attend at least 2 games. At least 2 games. How many different combinations of games can you attend? At least 2. So it's okay. You have 9 scheduled games. So you could do 2, 9 choose 2, or you could choose 3. You go to 3 of the games, or 9 choose 4, any 4 of those games. 9 choose 5, or 9 choose 6, 9 choose 7. You could go to 8 of the games. You go to, whoops, don't make that, that's not a fraction. You go to all 9, 9 choose 9. Okay? And this will end up spitting out final answer. There's 502 different ways on this. If you punch each of those, 9 choose 2 into the formula, 9 choose 3 and so on, and then you add up all those numbers. So there's 502 different ways, okay? Well, combinations are really handy when you're expanding binomials, okay? So for example, before we look at that, the binomial theorem there, let's look at x plus 5 to the third. Now we know x plus 5 to the third is x plus 5 times x plus 5 times x plus 5, right? And we could expand this, right? So we'd FOIL that first, x squared plus 5x plus inside plus the 25. Combine those. Of course, we still got x plus 5. We got to do that again. So we got x squared plus 10x plus 25. And then we multiply that by x plus 5, right? We take the x through. So x cubed, we got the 10x squared. We got the 25x. Then we take the 5 through to each of those, right? 5, each of those. So 5x squared, 50x, 125. So this ends up being x cubed. Combine your x squareds. So we got what? 15x squared. Combine the 25x, 50x, 75x. And you got the 125. Okay? So that's how we would expand it old school, right? In fact, let me write this out. X cubed, 15x squared, 75x, 125, okay? Now, the binomial theorem, well, and think about this for a minute. What if this was x plus 5 to the 30th, right? Would you want to do that? X plus 5, x plus 5, x plus, 30 of those. Would you want to FOIL that out, combine them, all that stuff? No, there's no way. Okay, it'd be a nightmare. So you have this binomial theorem expansion, which uses a combination. Okay, so here's how it rolls for it. What you do is you see how your x is your a, right? Your 5 is your b, and your 3 is your n. Okay, and it's n choose r, a to the n minus r, b to the r, and we're going to let r be 0 initially. Okay, so first of all, it's 3 choose r, and we're going to let r be 0 initially. And then our a is our x, right? So it goes x to the n minus r. N is our 3, so 3 minus 0, 3. And then our b term is 5, okay? And that's going to be to the r, which is 0 initially, okay? And then the next one is, now our r is going to be 1. So we go 3, choose 1. X is now squared, so it goes n minus r because r is 1. 3 minus 1 is 2. And then 5 will go up 1. Now notice these two are always going to add up to the power. It is. Okay, you notice 3 plus 0, 3, right? Both of those, they're going to add up to 3 each time. Okay. Let's keep going. Now our r is 2. 3 choose 2. X, and you see how the x keeps going down. It was x cubed here, then it's x squared. Now it's going to be x to the 1 power. And our 5, oh my gosh, I wrote that wrong right there. Our 5 was initially 0, and then it went up to 1, and then now the 5 is going to go up squared, right? 5 to the r, so r is now 2 now. Okay, and our last term is 3 choose 3. Okay, and choose r. So as soon as they're the same there, it's going to be your last one. X is now to the 0 power. Okay, again, the x started at x cubed on the first term, then squared, then to the 1, now to the 0. And 5 was going up. It started at 0, then it went to 1, right? Then it went to 2, now it's to the third. Okay? Now we punch those in. So 3 choose 0. So you would do 3 choose 0 on the side, and that gives you 1. Okay? X to the third. Anything to the 0 power is 1. Okay? Plus, okay, now we got 3 choose 1. So you'd go to the side, you do the 3 choose 1, 3 factorial over 3 minus 1 factorial, 1 factorial, 3, 2, 1, over 3 minus 1 is 2, 1, 1. And you got 3, right? So this is 3. And you got x squared, 5 to the 1 is 5, plus, and then you do 3, choose 2, and it happens to also be 3. And then you got x to the 1, 5 squared is 25. 3, choose 3 is 1. X to the 0, anything to the 0 is 1. 5 cubed, 125. Okay, let's clean this up. So we got 1 times 1, 1x cubed. 3 times 5, 15x squared. 3 times 5, 25x. 1 times 1 times 125, 125. There's the expansion of x plus 5 to the third using the binomial theorem. Okay? Like, let's do another one with, let's do, you know what, I got one right here. A minus 2b to the fourth. First of all, let me put this in a plus. Think about that as negative 2b and all of this to the fourth. Okay, so here's my a is my x, negative 2b is my y, and to the fourth power. Okay, let's expand this. So this goes n choose r, and we're going to let r be 0 first. So 4 choose 0. Okay, a is to the fourth power. This negative 2b is to the 0 power. And then I'm going to go 4 choose 1. A now goes down to the third power, and that negative 2b goes up to the first power. 4 choose 2. A now goes down squared. Negative 2b will go up squared. 4 choose 3. A now goes down to the first power, whereas negative 2b will go up to the third power. And finally, 4 choose 4. A goes now to the 0 power, negative 2b goes to the fourth power. Okay, and now we gotta expand this. So 4 choose 0 is 1. A to the fourth is just a to the fourth. Negative 2b to the 0, that's negative 2 to 0, b to the 0. Both of those, anything is 0 is 1. Okay, 4 choose 1 is 4. A to the third, a to the third, and then I got negative 2 to the 1, and I got b to the 1, right? I got 4 choose 2, which is 6, and then a squared, negative 2 squared, and then I got b squared. I have 4 choose 3, which is 4, a to the first power, negative 2 cubed, which is negative 8, b cubed, and then 4 choose 4, which is 1, a to the 0 is 1, and then this is negative 2 to the fourth, and b to the fourth. Okay, so we clean that up, a to the fourth plus 4 times negative 2, so we got negative 8, a cubed b, and over here we got 6 times, now negative 2 squared is 4, so 6 times 4, 24, a squared, b squared, plus, over here we got 4, and that negative 2 cubed again is negative 8, right? So 4 times negative 8, negative 32, I got an a to the first, b cubed, and then over here 1 times 1 times, now negative 2 to the fourth is positive 16, so 16 I got b to the fourth. Okay, so this ends up being, let me write it one more time, a to the fourth minus 8 a cubed b plus 24 a squared b squared minus 32 ab cubed plus 16 b to the fourth. Okay, that's our binomial expansion of a minus 2b all to the fourth. Okay, so that's rolls, and that would take forever if you were to do that. It took long enough with the binomial theorem. But now let's do find the coefficient y to the sixth in the expansion of. So they just want the coefficient of the term that has y to the sixth in it. Okay, an expansion of y minus 8 minus y to the eighth. I'm sorry, 8 minus y to the eighth. 8 minus y to the eighth. Now I'm going to think about that again as 8 plus the negative y to the eighth when I expand this, right? So I'm looking at my eighth power, right? So eighth power. So 8 choose 0. It's going to be 8 to the 8th. And then negative y is going to be to the 0. Plus 8 choose 1. 8 is now to the 7th. Negative y is to the 1. 8 choose 2. 8 is now to the 6th. Negative y is now squared. 8 choose 3. 8 is now to the 5th, whereas the negative y is to the 3rd. And you can probably see the pattern here. 8 choose 4th, negative y to the 4th. Let me go down here. 8 choose 5. 8 is to the 5th. Negative y is to the 3rd. 8 choose 6. 8 is to the, whoops, 5th, what am I doing? 4th, whoops, that last one. Sorry about that. Mixed that one up. Hee hee. I had 8 choose 4, so I gotta go 8 choose 5. But my 8 has got to go down to the 3rd. Sorry about that. Negative y goes up to the 5th. 8 choose 6. 8 goes down squared. Negative y goes up to the 6th. 8 choose 7. 8 goes down to the 1st. Negative y 7th. And finally 8 choose 8. 8 goes to the 0th power. Negative y goes to the 8th power. Okay, and this is the one we're concerned about. You see how that is the one where you're going to have y to the 6th in there? So we want the coefficient here. Okay, so you got to be careful. First of all, you want to punch in 8 choose 6. Okay, so punch in 8 choose 6, figure that out, and this ends up being 28. Okay, 8 squared is 64. And then you got this negative 1 to the 6th, and then you got your y to the 6th. Okay, so 28 times 64, 1792. Of course, negative 1 to the 6th is just a positive 1, and you got y to the 6th. So this ends up being 1792 y to the 6th. That is the coefficient that we were looking for, was that 1792. Okay, thanks for listening, you guys. Make sure you bring any questions in class about the binomial theorem or combinations or any of that stuff.